Hi everybody. In this video I'm attempting to review a little bit more with reading graduated cylinders and reading graduated cylinders to help you do water displacement. We're going to go through each one of these graduated cylinders to give you a little bit of extra practice, and hopefully this will help you understand a little bit more. We're going to start at A. What do you think the volume of the liquid in graduated cylinder A would be? The correct answer comes out to be 28.0 milliliters. The reason it's 28.0 is each one of these graduations go up, or tick marks go up by 1. So this here is 28. The reason it has the decimal place is it can be pushed to 1 decimal place. And you know that by asking yourself, if this is 28 and that's 29, what's in between 28 and 29? Well, 28.5 is dead in between there. Because you say 28.5, you know there must be a decimal or the chance of a decimal answer. That means because this is right on that 28, it's going to be 28.0. Let's go on to B. B comes out to be 34.0 milliliters. Again, each tick mark, each graduation goes up by 1. And this is right on 34 there, so it's right on that line. And because this, when they go up by 1, they're going to have a decimal place in the answer. Because if it would fall in between, it could be 34.1, 34.2, 34.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9. Anywhere in between here, you would guess just like you would on a meter stick, but you can only guess 1 decimal place. And because it's right on here, though, we're going to guess that it's 34.0. It would be the easiest and best guess. C. Well, the volume at C would be 85.0. Again, everything goes up by 1s. Because it's right on that 85, it's going to have a decimal of 0, decimal place of 0. Again, yes, could it be somewhere in between? Yes, but when we're reading it, our best educated guess is saying at the bottom of this meniscus here, it's at 85.0. Let's go to D now. D is going to be 39.0. That is going to be what the volume at D is. Again, everything goes up by 1s. When it goes up by 1s, you're going to get that decimal place in there. Let's look at E. The volume for E is actually 23 milliliters, no decimal place. And you're going to ask why. Well, when you read this, each graduation or each tick mark goes up by 2. 20, 22, 24, 26, 28, 30. The mark here, the water, is right in between 22 and 24. Well, ask yourself, what's between 22 and 24? 23. And because there's no marking in between, you don't know exactly where 23 is. So anywhere in between would be 23 because we don't know exactly where it's at. So when a graduated cylinder goes up by 2s, there can be no decimal places. It's just a whole number. Hopefully this helps you with reading the graduated cylinders a little bit. Well, now we're going on to water displacement, and we're looking at calculating the volume of the objects using water displacement, things that we can't use length times width times height for. So we start out remembering that the equation for water displacement is VO equals VF minus VI. VO is the volume of the object, in this case the metal rod that's inside the water. VF is the final volume. VI is the initial volume. Our initial volume is right here. That's your VI. What would be the volume right here, the VI? Well, VI actually comes out to be 19.0. Everything goes up by 1s and it's right on that line there, so it would be 19.0 milliliters. Then we've got to go right here, where this would be your VF. What would be the volume final, the final volume, VF? That comes out to be 29.0 because it's right there on the line. And again, everything goes up by 1s, so it's got to have a decimal place in the answer. Based on this information, what would be the volume of the metal rod? When you work through this, you plug 29.0 milliliters minus 19.0 milliliters equals 10.0 milliliters. Now, because that is a solid object, there are people that will say, well, it could be 10.0 cubic centimeters or centimeters cubed. That would be correct, and that would not be marked wrong on a test. I'm using milliliters to keep track with the units that were previously used to measure. So I just kept it in those units. Because cubic centimeters and milliliters can equal one another, you could have said 10.0 cubic centimeters. Let's move on to B here. Again, we have VO equals VF minus VI. The VI of this would be 64.0 milliliters. Everything goes up by 1. It's got to have 1 decimal place in the answer. The VF for this one, for the ring, after adding the ring, the final volume would be 68.0 milliliters. Remember, VI is before the object is added, and VF is after the object is added. So what would be the volume of the ring, VO? And you're going to go through and calculate that by taking 68.0 milliliters minus 64.0 milliliters, giving you an answer of 4.0 milliliters. So this is how you calculate water displacement. You're going to take the final volume, which is after you add the object, minus the initial volume, which is before you add the object. Hopefully this helps you calculate water displacement and also helps you reading the graduated cylinders. If you have any questions with this material or even this assignment, please feel free to email me and contact me, and I'll try to get back to you as soon as I can. Thank you, everybody. Don't forget to study for your test that's coming up on Monday, October the 5th. Have a good day.